Hello students, welcome back. So we are doing exercise 22a from trigonometry, isn't it? And we have completed till question number 10 in our previous video, and today we'll start right from question number 11 onward. Okay, so let's begin. So this is question number 11 from exercise 22a. Okay, so given cos A equals to 0.6, the value of cos A is given to us 0.6. Find all the trigonometrical ratios for angle A. So we are asked to find the remaining 5 trigonometrical identities. Okay, we know that there are 6 trigonometrical identities: sine, cos, tan, cot, sec and cosec. Okay, the value of cos A is given to us, trigonometrical ratio for cos A is given to us 0.6, and we are asked to find the remaining 5 trigonometrical ratios. Okay, so let's begin. Since cos A equals to 0.6, isn't it? Or cos A equals to 6 upon 10, isn't it? We remove a decimal point from numerator, okay, and introduce 10 in the denominator. Or, okay, now this is base and this is hypotenuse, isn't it? Curly brown hair, base upon hypotenuse. Okay, now base is given to us, base is 6 and hypotenuse is 10. So we need perpendicular, isn't it? So perpendicular is question mark. So let us apply Pythagoras theorem to find perpendicular. Okay, since we know that p square equals to h square minus b square, this is the Pythagoras theorem. Or p square equals to, what is h? H is 10, 10 square minus b is 6 square. Okay, or p square equals to 10 square is 100, okay, minus 6 square is 36, isn't it? Or p equals to root under 10 minus 6 is 4, isn't it? This becomes 9, 9 minus 3 is 6. So this square goes to the right hand side and becomes root. Or p equals to root under 64 means 8, isn't it? 8 is the 64. So root under 64 is 8. Okay, we found perpendicular, isn't it? So let us write 8 here. Perpendicular is 8. Now let us find sine A. Okay, sine A. Since sine A equals to perpendicular upon hypotenuse, some people have, isn't it? So what is perpendicular? Perpendicular is 8. And what is hypotenuse? Hypotenuse is 10, isn't it? 10. So 2 4s are 8, 2 5s are 10. This gives us 4 upon 5, isn't it? Now cos A, we know cos A. Let us find tan A. Tan A equals to turns permanently black, isn't it? Tan theta is p by b. What is perpendicular? Perpendicular is 8. So we write 8 instead of p. What is base? Base is 6, isn't it? This is 6. So 2 4s are 8, 2 3s are 6, isn't it? So 4 upon 3 means 3 1s are 3 plus 1 is 4. 3 1s are 3 plus 1 is 4. 4 upon 3. Okay, this is an improper fraction because the denominator is smaller than the numerator, so we convert into mixed fraction. Cot A. Now cot A equals to b by p, isn't it? Opposite of tan A is cot A. So what is base? Base is 6. Base is 6. And what is p? P is 8. Okay, base is 6 and p is 8. Perpendicular is 8. 2 3s are 6, 2 4s are 8. So this is proper fraction. So 3 upon 4 we write as it is. Okay, sec A. Sec A is just the opposite of cos A, h upon b. Okay, h upon b. Now what is h? H is hypotenuse. Hypotenuse is 10, isn't it? And what's base? Base is 6. So 2 5s are 10, 2 3s are 6, isn't it? So 5 upon 3 means 1 whole 3 2, isn't it? 3 1s are 3 plus 2 is 5, 5 upon 3. Okay, 5 upon 3 is an improper fraction, so we convert into mixed fraction. So cosec A cosec A equals to opposite of sine A, okay, h by p. H is hypotenuse, hypotenuse is given to us 10, and p is perpendicular, perpendicular is 8. So 2 5s are 10, 2 4s are 8. So 5 upon 4 is an improper fraction. Let us convert into mixed fraction. 1 whole, 4 1s are 4 plus 1 5, okay. 4 1s are 4 plus 1 5. 1 whole 1 upon 4. So 1 2 3 4 5, and this is 6, okay. Cos is 6 by 10, isn't it? So these are the values of remaining 5 trigonometrical ratios, okay. So let us move on to the next question. Question number 12. In a right angled triangle, it is given that A is an acute angle and tan A equals to 5 upon 12. The value of tan A is given to us. Find the values of cos A, sin A, and cos A plus sin A upon cos A minus sin A. So we are asked to find the values of this, okay. Acute angle is nothing but less than 90 degree. Acute angle means any angle less than 90 degree. Acute angle is less than 90 degree, okay. Right angle equals to 90 degree. Obtuse angle means greater than 90 degree, okay. If the angle is greater than 90 degree, then it is called obtuse angle, okay. If the angle is equal to 90 degree, then we call it right angle. If the angle is lesser than 90 degree, then we call it acute angle, okay. Now tan A is given to us 5 upon 12, okay. Since the value of tan A is given to us, tan A equals to 5 upon 12, isn't it? So tan theta is perpendicular upon base, isn't it? So P is 5, B equals to 12, hypotenuse equals to question mark. We don't know hypotenuse, isn't it? Now let us find hypotenuse by applying Pythagoras theorem, okay. Since we know that h square equals to p square plus b square. This is Pythagoras theorem, isn't it? H square equals to p square plus b square, or h square equals to p is 5, okay, square plus b is 12 square, okay, or h square equals to 5 square means 25, 12 square means 144, okay, or h equals to 5 plus 4 is 9, 4 plus 2 is 6, 1 we write here, this square we take to the right hand side, becomes square root. H equals to 169, root under 169 means 13, okay, because 13 into 13 gives us 169, so root of 169 is 13. So we have hypotenuse, okay, the value of h is 13. Now let us find the value of cos A. Cos A means curly brown hair, base upon hypotenuse. And what is base? Base is 12. And what is hypotenuse? Hypotenuse is 13. So this is the answer for cos A, value of cos A, okay. Value of cos A is 12 upon 13. What is sin A? Sin A is, some people have perpendicular upon hypotenuse. What is perpendicular? Perpendicular is 5 upon hypotenuse. Hypotenuse is 13, isn't it? So this is the answer for sin A. The value of sin A is 5 upon 13, okay. Now cos A plus sin A upon cos A minus sin A. So what is cos A? Base upon hypotenuse plus sin A means perpendicular upon hypotenuse. Cos A means base upon hypotenuse minus sin A means perpendicular upon hypotenuse. Some people have, okay. So what is base? Base is 12, isn't it? 12, hypotenuse is 13 plus perpendicular is 5, isn't it? Perpendicular is 5 upon hypotenuse is 13, whole upon base is 12 upon hypotenuse is 13, isn't it? Hypotenuse is 13, base is 12, perpendicular is 5, okay, minus perpendicular is 5 upon hypotenuse is 13. Now let me continue here. So the LCM is same number, isn't it? 13 and 13. So LCM will become 13. If the denominators are equal, then we just write the numerators as it is. Okay, 12 plus 5 whole upon, here also the denominators are equal, so LCM will be 13. In the numerator we have 12 minus 5. Now this 13 and 13 can be cancelled. Okay, 13 can be cancelled, so 12 plus 5 is 17 upon 12 minus 5 is 7, isn't it? 12 minus 5 is 7. So 17 upon 7 is the answer. So let us convert this into mixed fraction. 7 2s are 14, 7 2s are 14, 15, 16, 17, 3. So the value of cos A plus sin A upon cos A minus sin A is 2 whole 3 upon 7. Okay, I hope you got this. Now let us move on to next question. Let's do question number 13. Given sin theta equals to P upon Q. The value of sin theta is given to us, P upon Q. We are asked to find the value of cos theta plus sin theta in terms of P and Q. Okay, so this is also the similar type of question as we did earlier. Since sin theta equals to P upon Q, isn't it? So this is perpendicular upon hypotenuse. Some people have, isn't it? So perpendicular is P, perpendicular is P. Okay, hypotenuse equals to Q, base equals to question mark. We don't know base, isn't it? Now let us apply Pythagoras theorem to find the value of base. Okay, since base square equals to hypotenuse square minus perpendicular square, isn't it? Or base square equals to what is h? H is q, isn't it? Q square minus what is p? P is p, isn't it? P square. Or b square. Okay, so we take this square to the right hand side, root under q square minus p square. So b equals to root under q square minus p square. This square when taken to the right hand side becomes root, isn't it? So q square minus p square. So we found b, isn't it? So b is root under q square minus p square, isn't it? Q square minus p square. Okay, this is base. Now let us find the value of cos theta plus sin theta. Cos theta plus sin theta. Cos theta plus sin theta equals to, cos theta is base upon hypotenuse, curly brown here, plus sin theta is perpendicular upon hypotenuse, isn't it? So we take h, LCM, b plus p. Now what is base? Base is root under q square minus p square. Root under q square minus p square. Q square minus p square. Okay, plus what is p? P is perpendicular, perpendicular is p, whole upon what is h? H is hypotenuse, hypotenuse is q. Okay, so this is the answer. This is the value of cos theta plus sin theta. Okay, root under q square minus p square plus p upon q. I hope you got this. So this is the value of cos theta plus sin theta in terms of p and q. Okay, so let us do the next question. Question number 14. If cos A equals to 1 upon 2 and sin B equals to 1 upon root 2, find the value of tan A minus tan B whole upon 1 plus tan A into tan B. Okay, so the value of cos A and sin B is given to us. We are asked to find the value of that expression, isn't it? Please note the angles are different, A and B. Okay, curly brown here. Hypotenuse is 2 in this case. Some people have hypotenuse is root 2 in this case, isn't it? So different hypotenuse means two different right angle triangles, isn't it? So let us find perpendicular base and hypotenuse for different right angle triangles. First case, since cos A equals to 1 upon 2, base upon hypotenuse, curly brown here, isn't it? So for the first right angle triangle, let us represent B1 and H1. Base B1, hypotenuse is H1. Okay, so B1 is 1, H1 is 2. B1 for the first right angle triangle, base is 1, hypotenuse is 2. So perpendicular P1 equals to question mark. We don't know the value of perpendicular, isn't it? Applying Pythagoras theorem, let us find the value of P1, that is perpendicular. Since P1 square equals to H1 square minus B1 square, isn't it? Or P1 square equals to H1 is 2, 2 square minus B1 is 1, 1 squared. Or P1 squared equals to 2 squared is 4, minus 1 squared is 1. Or P1 equals to 4 minus 1 is 3, isn't it? 4 minus 1 is 3. Square when taken to the right hand side becomes root. So P1 is root 3. That means we found P1. P1 is root 3. Okay. Perpendicular for the first triangle is root 3. Hypotenuse to base is 1. Okay. Now let us see the second triangle, sin B. Since sin B equals to 1 upon root 2, isn't it? Some people root 2, 1 upon root 2. Okay. Some people have perpendicular H1 P2, hypotenuse H2. Okay. So since P2 perpendicular for the second triangle P2, okay, is 1, H2 hypotenuse for the second triangle is root 2. Now base unknown to us, so B2 equals to question mark. Okay. Applying Pythagoras theorem, B2 squared equals to H2 squared minus P2 squared, isn't it? Or B2 squared equals to what is H2? H2 is H2 root 2. Root 2 squared minus what is P2? P2 is 1. 1 squared, isn't it? So let me continue here. Okay. So B2 squared or B2 squared equals to root 2 squared is 2, isn't it? Root 2 into root 2 is 2 minus 1 squared is 1. Okay. Or B2 equals to 2 minus 1 is 1. So square when taken to the right hand side becomes root. So B2 equals to 1. Root 1 means 1. Okay. So we found the value of B2. Value of B2 is 1. Now let us find the value of this expression. Since tan A minus tan B whole upon 1 plus tan A tan B, 1 plus tan A into tan B. Okay. For angle A means first right angle triangle, this case. Okay. So tan A is P1 by B1 perpendicular by base minus tan B is perpendicular by base but P2 B2. Okay. Now 1 plus tan A is P1 by B1 into tan B is P2 by B2. Okay. Now this gives us P1 is perpendicular 1, P1 is root 3, P1 is root 3 upon B1 is 1. Okay. Minus P2 is 1, P2 is 1, B2 is 1 whole upon 1 plus P1 is root 3, B1 is 1. Okay. Into P2 by B2. What is P2? P2 is 1 upon B2. B2 is 1. Okay. So root 3 upon 1 minus 1 upon 1. Root 3 upon 1 is root 3 minus 1 upon 1 is 1 whole upon 1 plus. Okay. Root 3 upon 1 is 1. Sorry. Root 3 upon 1 is root 3 into 1 upon 1 is 1. Root 3 into 1 is root 3. Isn't it? Root 3 upon 1 means root 3. 1 upon 1 means 1. Root 3 into 1 is root 3. Okay. So root 3 minus 1 upon 1 plus root 3. Root 3 minus 1 upon root 3 plus 1, isn't it? This is root 3 minus 1 upon 1 plus root 3 can be written as root 3 plus 1, isn't it? 1 plus root 3 and root 3 plus 1, same thing. So this is the answer actually, but we cannot leave like this because we cannot leave numbers having root in the denominator. Okay, so we need to rationalize this. So let us rationalize this number. So how do we rationalize this? We write the same number, root 3 and 1. Okay, now here if we have plus sign, we write minus sign. Okay, multiplying and dividing by root 3 minus 1. If this was minus 1, then we will write root 3 plus 1 upon root 3 plus 1. Are you getting me? Okay, now in the numerator we have root 3 minus 1 into root 3 minus 1, that is root 3 minus 1 whole squared. In the denominator we have root 3 plus 1 into root 3 minus 1, isn't it? This is assumed as A and this is assumed as B. Okay, now A plus B into A minus B. What is the value of formula for A plus B into A minus B? A plus B into A minus B is A square minus B square, isn't it? So A plus B into A minus B is A square minus B square. A is root 3, B is 1. Okay, so root 3 minus 1 whole square. Now A minus B whole squared. A minus B whole squared is A squared minus 2AB plus B squared, isn't it? A squared minus 2AB plus B squared. Now root 3 squared is 3. Root 3 into root 3 is 3. Minus 1 squared is 1. Okay, so root 3 squared is 3 minus 2 1s are 2 into root 3 plus 1 squared is 1. Okay, so 3 minus 1 is 2. So plus 3 plus 1, both are positive. 3 plus 1 is 4 minus 2 root 3, isn't it? Whole upon 2. Whole upon 2. Now let us take 2 common from the numerator. 2 2s are 4. Plus into minus, minus. 2 into root 3. 2 2s are 4. Plus into minus, minus. 2 into root 3, 2 root 3. Okay, so from the denominator we have 2 and 2 cancelled. 2 minus root 3 remains, isn't it? So 2 minus root 3 is the answer for question number 14. Okay, the value of this expression is 2 minus root 3. I hope you got this. Now let us move on to the next question. Okay, question number 15. If 5 cot theta equals to 12, find the value of cosec theta plus sec theta. Okay, so given is 5 cot theta equals to 12, isn't it? Since 5 cot theta equals to 12, okay, or cot theta equals to 12, this 5 goes to the denominator by cross multiplication, isn't it? Cot theta equals to 12 upon 5, this 5 goes to the denominator of the right hand side. Okay, so cot theta is B by P, isn't it? B by P. So we have base as 12, perpendicular as 5, so hypotenuse is unknown to us. Okay, now let us find hypotenuse first. So applying Pythagoras theorem, h square equals to p square plus base square, isn't it? Or h square equals to, what is p? P is 5 square plus base is 12 square, or h square equals to 5 square is 25 plus 12 square is 144, or h equals to 5 plus 4 is 9, 4 plus 2 is 6, 169. This square taken to the right hand side becomes root, or h equals to root under 169 means 13, isn't it? 13 is 169, so root under 169 means 13. So we found hypotenuse is 13. Okay, now cosec theta plus sec theta, isn't it? Let us find the value of cosec theta plus sec theta. Cosec theta plus sec theta. Okay, so cosec theta is hypotenuse upon perpendicular plus sec theta is hypotenuse upon base. Hypotenuse upon base. Okay, so what is hypotenuse? Hypotenuse is 13, and what is perpendicular? Perpendicular is 5 plus hypotenuse is 13, base is 12. So the LCM of 5 and 12 is 5 12 is 60, Now 5 12 is 60, so 12 into 13, isn't it? 12 3 is 36, 6 3 in hand, 12 1 is 12 plus 3 is 15, plus 12 5 is 60, so 5 into 13, 5 3 is 15, 5 1 is 5 plus 1 is 6, 65. 6 plus 5 11, 5 plus 6 11, 11 plus 1 is 12, 2, so 1 2, isn't it? 2 to 1, 2 to 1 upon 60. So this is the answer for question number 15. Okay, so this is an improper fraction. We can convert this into mixed fraction. Okay, 2 to 1 by 60. 6 4 is 24, 6 3 is 18, 6 3 is 18, 3 0 is 0, 3 6 is 18. Okay, 1, 12 minus 8 is 4, isn't it? So this is 1, 1 minus 1 is 0. So 3 whole 41 upon 60. You can write this. Okay, so the answer for question number 15 is 3 whole 41 upon 60. I hope you got this. Okay, this was for today. Thank you so much. Stay connected. Okay, I'll upload the rest of the questions in the next video. Thank you so much.